Okay, we are continuing with our guide for OLI Mod 8. We've finished up taking a look at two measures of center, the mean and the median. We know that distances are balanced on each side of the mean. We know that the number of pieces of data are balanced on each side of the median. But now that we have those two measures of center, the natural question is, well, when do I use either one? How do I make that decision? And the answer is we're going to consider two things. We're going to consider the shape of the distribution and the presence of outliers. So over on the right hand side here of our video, I've got a page brought up from OLI. This is data on some homework scores. And what we notice is that most of those homework scores are gathered up here in the 70 to 80% range. And certainly, aside PSA, your checkpoint scores should be up there as well because, of course, you have 4 attempts at every checkpoint. You can ask questions of me. You can ask questions of tutors in the Math Center for help if you need it. So always make sure you understand what is on those checkpoints. Okay, so back to this. Most of the data is up here, but we've got this outlier way down here at 0. Either this student didn't do their homework or just really did not understand what was going on and ended up getting a 0. And if we think about how the mean and the median are calculated, right? The median is putting an equal number of pieces of data on each side of it. So whether this piece of data is down here at 0 or if it was a second piece of data up here at 70, that median wouldn't move at all because this piece of data, as long as it's anywhere to the left of the median is not going to change. And so the median is very resistant to this outlier. This piece of data can go moving all over the place. And as long as it doesn't go past this median line, then that median doesn't change at all. But of course, the mean, if we think about how the mean is calculated, we're adding up all our data values. Well, if a 0 is included in that sum, or if we moved it up to 70, if a 70 replaces the 0 in that sum, that's going to make a very big difference in that mean. So the mean is always pulled off in the direction of outliers. The mean is not resistant to those outliers. So if we have an outlier in a data set, then the median is going to be our better measure of center. Take a note down here though, this data set is very similar, except it's got a lot fewer data values. And so now that outlier of 0 affects the mean even more, and it pulls it down even further than it did up here when we had a lot of data. But either way, the mean is going to move in the direction of that outlier. It's going to move farther. The fewer data pieces you have, the more data pieces you have, it won't move as far, but it still will move. Okay, so let's see over here. Let's maybe start making a list. So the median is going to be our better measure of center if outliers are present. Okay, let's take a look now at skewness. So hopefully you recognize this data here. So this is US Census data, personal income. So personal income, salary is generally something that's always going to come in skewed to the right. A lot of individuals are have incomes, have salaries on the low end of the schedule. And then, of course, there are a few individuals that are making salaries on the very high end of that data set. So as we take a look at the median and the mean here, again, although the mean is pulled up by this high data, by this skewness to the right, it really isn't coming out with a very representative value of the large amount of people with very low incomes. So when we have a skewed data set, highly skewed one way or the other, that is another instance in which the median is our best measure of center. So let me add that back over here. When we have skewed data sets, the median is our best measure of center. That really doesn't leave much for when we would use the mean as our best measure of center. Essentially, there needs to be no outliers and no skewness. OLI goes a little bit further and says that we should essentially have a bell-shaped distribution in order to be able to use the mean as the best measure of center. But also keep in mind that anytime the mean is good, when there are no outliers, when our data set is essentially bell-shaped, the mean is approximately going to equal the median, which means that actually under these circumstances, bell-shaped, no outliers, both the mean and the median are equally good. Let's take a look how this applies to our serial data. So that's what we're going to look at next. Now, although I have all of the histograms for that serial brands data set we used last time, although it's all here, never pass by an opportunity to practice your stat crunch because it's going to be so important for the test. So I'm going to start here from the home page. Remember that we load our data sets by clicking on data sets, and then we can put some keywords in our search box. I'm just going to search for cereal, and this is the one we wanted, cereal brands owned by StatCrunch Featured. So I'm going to load that back into my data set. Histograms happen in the graph drop down menu, and then we pick histogram. We're going to make a histogram for every one of these columns. So I click the first, and then I shift click the second to choose that entire block. We're not going to worry about most of these things. We're going to let StatCrunch set up the bars or the bins itself. I could ask StatCrunch to do something specific here, but I'm fine with however StatCrunch wants to do it. I am going to set this bottom section in this case. I would like multiple graphs to all show up on one page. I have set this up for 3 rows and 4 columns is what will match what I've got on our guide there, and then we're just clicking compute, and what we see on the right hand side is exactly what I've got on our sheet here. So what we're supposed to be doing here, choose those variables for which only the median is the best measure of center. So we know that the median is going to be best if we have skewness or if we have outliers. And let's kind of take a look at all these questions before we look to those data sets. List those variables for which only the mean is the best measure. Well, honestly, we can fill that in right now. That is going to be none of them, because remember that if the mean is good, the median is also good. So there's really no time. in which the mean is the only best measure. C lists those variables for which both the mean and the median are equally good measures of center. So that's going to be our data sets that have a fairly bell-shaped distribution without outliers. Why don't you go ahead, pause the video, take each one of your variables and put them in either one of these categories, just the median or both the mean and the median are equally good, and then we'll take a look at our choices. Okay, you can see from my answers here that really the only thing that I put down for which I thought the mean would work reasonably well is calories. I know that in the histogram there is sort of a break in that 60 to 70 range, but I don't think these cereals here in the 50 to 60 range are far enough away to make them outliers, nor do they really fit outside the pattern of the data. One thing I did notice that I wrote carbohydrates here in gray, and that's because honestly I think the carbohydrates are a bit of a gray area. They are fairly bell-shaped. Maybe we shouldn't get hung up in this little dip right here. Certainly, you know, the thing we might do in that case then is just go ahead and calculate both the mean and the median for those data sets for that carbohydrate and kind of see where it falls. The weight is pretty symmetric, but I feel like that overwhelming majority of data right here in the center means that both our very low and our very high values there might be outliers. Again, if you came in a little differently on these, there is a lot of gray area here. Certainly something like fiber, very skewed, that should definitely be the median. I think maybe we should also all agree that calories is enough of a symmetric bell-shaped distribution that the mean is a fine measure of center there.